Good morning, everyone. And in this class, we will be dealing with friction. We'll not go into much detail because we don't have sufficient time. Whatever we are going to cover is going to be very pinpoint and very accurate. Whenever we talk about friction, we can talk about two types of friction. Yes or no? Do we know this? One friction is known as,
static friction,
and the other friction is known as
kinetic friction.
kinetic friction. Yes or no?
Yes, sir.
Now, this kinetic friction is also sometimes known as sliding friction, and we will first deal with the sliding friction. Okay, so we'll first write the heading kinetic friction. Kinetic friction. Now, as I always told you, whenever you keep two bodies in contact, the two bodies will exert forces on each other. That force is known as your what? That force is known as your contact force. Yes or no? Now,
Yes,
this
sir.
contact force can be resolved into two components. We have seen the first component. So if I let us say a block of mass m is sliding on the floor with, let us say, a velocity v. If I draw the free body diagram of this body, mg would be the weight of the body which is acting downwards. Now this body is kept on a floor or on ground. It would be exerting force on the ground. The ground would also be exerting force on this. And in this case, the force actually goes in this direction. This force is known as the, which force?
Reaction force.
Reaction force. This reaction force can be resolved into two components. One component is known as the normal reaction force, and the other component is known as friction. Do we understand this?
Yes, sir.
Now, in this particular case, this normal reaction and there is a relation between this frictional force and this normal reaction force. This frictional force, in case of a moving body, sliding body, kinetic friction, this frictional force is always equal to mu k into n, where mu k is a constant which depends on the surfaces between them, between the surfaces. What type of surfaces are there? Whether the surfaces are lubricated, whether the surfaces are rough, between any two surface, this mu k depends on. This mu k does not depend on area of contact. Unless and until the surfaces are same, it does not depend on area of contact. Do we understand this? So if I keep a body like this, or if I keep the body like this, or if I keep the body like this, the value of mu k remains same unless you change the surface. One surface is different and the other surface is different. Do we understand this?
Yes, sir.
It only depends on the two surfaces which are in contact. This friction, this force is known as kinetic friction or kinetic friction force. I will just call it frictional force. And remember, what does this frictional force do? This frictional force is a force, so it has two things. This is the magnitude of the force. Do we understand this?
Yes, sir.
This frictional force also has a direction. What is the direction of friction force? Remember, whenever we hear about friction force, we always say that friction force or friction opposes motion. Does friction oppose motion? Friction does not oppose motion. Friction only opposes relative motion. Friction does not oppose motion. In fact, it is because of friction that I am able to write on this tablet. It's because of friction that you are able to write on your books. It's because of friction that you can walk. It's because of the friction that your car moves forward. If there is no friction, life is going to be very, very sick. Friction does not oppose motion, it only opposes relative motion. So direction of this frictional force will be such that it will oppose relative motion. As you can see, if I become this block, if I become this ground, if I stand on this ground, what will I see? If I stand on ground, I will see that the block is moving forward. Yes or no? So as a ground, I will apply frictional force on the other body. The other body is trying to move forward. I want to oppose the motion because relative to me, it is moving forward. So what will I do? I will apply frictional force in the opposite direction. Do we understand this? So what are the things that you must remember about kinetic friction or any friction? Friction does not oppose motion. It only opposes
relative motion.
the value of kinetic friction is always equal to the value of kinetic friction is always equal to
Mu k into n, sir.
mu k into n. If you want to change the value of kinetic friction, either you change the value of mu k. How can you change the value of mu k?
By changing the surface.
By changing the surface. Can you change the value of mu by changing the area?
No, sir.
No, unless you change the surface. Or you can change the value of mu by changing the value of n. If this becomes inclined plane, the value of n will not be equal to mg. Yes or no? It will be equal to mg cos theta. Yes or no? So the
Yes, sir.
value of friction would be changed. So that is what you need to remember. And what is the direction of friction?
Opposite to relative motion.
Opposite to relative motion. Do we understand this? This is all about kinetic friction that we need to know. Once we understand this, we should be able to solve some problem. Now, before going into problem, let us understand this reaction force also, because you might get a question on reaction force. Now, this reaction force R, if I talk about the magnitude, it will be under root of F square plus N square. Yes or no?
Yes, sir.
This F is mu into N. So I can write it as mu square N square plus N square. Yes or no? I can take N common. I can write it as mu square. When I write mu, I mean mu k. Mu k square plus 1. Do we understand this? Yes or no? No, yes?
Yes, sir.
This reaction force makes an angle theta with the normal reaction. This theta is known as angle of friction. This theta is known as angle of friction. And the value of this tan theta is Fk divided by N. Now Fk is mu k into N. So this tan theta simply becomes equal to mu k. Do we understand this? Do we understand this, my dear friends?
Yes, sir.
This is known as angle of friction. Now there is also one more angle which is known as angle of repose. So let us write what is angle of repose. Have you heard about angle of repose?
Sir.
Angle of repose. Have you heard about angle of repose?
No, sir.
Okay, sir. Angle of repose. Suppose you must have done this experiment in your 11th standard. Suppose you have a block. This is a block which is kept on a inclined plane, and this inclined plane is rough. So if the inclination is very less, this block will not slide. Yes or no?
Yes, sir.
But if we keep on increasing this angle, at some point the block will start to slide. Yes or no?
Yes, sir.
That angle theta is known as the angle of repose. So angle of repose is that minimum angle of inclination at which a body placed on a incline starts to move down. Do we understand this? And this angle of repose, just remember that it is always equal to the angle of friction. It's always equal to the angle of friction. Do we understand this? This angle of repose is always equal to the angle of friction. Note it down, please. Once you are done, please let me know. You don't have to write the entire thing, beta. Be smart. You just have to write this is the angle where the block begins to slide. You don't have to write the entire English language. You can use your own language that you understand. If you are just copying down everything from the whiteboard, it is not going to serve any useful purpose. Do we understand this?
Yes, sir.
Please don't write everything as it is on the board. Just understand angle of repose. The angle at which begin to slide. Write it in your language. That's it. You're done. No one is going to ask you define. Will you get a question in JEE? Define angle of repose. So you will write the angle of repose is the angle and you will write it in on. You are done with 12. Yes. You don't need that. Okay. So be smart. Let us move ahead. Let me give you a question straight away on this without any thing. I hope you are ready to solve question. Yes or no?
Yes, sir.
So let me give you the सबसे simple one first so that you get used to your thing. This is a 5 kg block. It is kept on a rough surface. The coefficient of kinetic friction is given as 0.2. I apply a force of 40 newtons on this block. You have to tell me these things first once, so that once you are done, you can do it. Fk, do you understand the meaning of Fk?
Yes, sir.
And R, do you understand the meaning of R?
Yes, sir.
What?
Reaction force, sir.
Theta and A. Theta,
Angle of repose.
A, at theta angle of repose, angle of friction. Angle of repose only comes when you have an inclined plane, nothing else. And A,
Acceleration.
2 minutes is what you get. Just but any answers?
Sir, final acceleration is pending 1 minute.
Okay. Shall I do it for you? Okay. I've seen in your sheet also there are question of friction, so you can try them. It's a sheet that has both friction as well as Newton laws of motion. I thought that I send you the different sheet, but I've opened the sheet. It has both, so try the questions from there. Okay, so how are we supposed to do this? We are supposed to draw a free body diagram. Weight is 50 Newton.
We have done it, sir.
Normal reaction is N. Yes or no? As soon as you know the normal reaction, this body is going to move forward. Yes or no? With an acceleration A. Yes or no?
Yes, sir.
So the friction force will act backwards. Yes or no?
Yes, sir.
Now let us write the answers. Normal reaction N will be equal to 50 newtons. First part, everyone got this correct?
Yes, sir.
Kinetic friction will be mu k multiplied by 50. So 0.2 multiplied by 50, it is 10 newtons. Yes or no?
Yes, sir.
Okay. Reaction force will be under root of 50 square plus 10 square, whatever it comes.
10 root 26.
10 root 26. The value of tan theta is nothing but equal to 0.2. Yes or no?
Yes, sir.
Yes, sir or no, sir?
Yes, sir.
Now I have to find the acceleration. How will I find the acceleration? Do what we have been doing. Look at the forces in the direction of acceleration. So what is the equation for acceleration here?
F minus Fk equals to Ma.
40 minus Fk is 10. Yes or no?
Sir.
Is equal to M, 5A. So you get acceleration as 6 meter per second square. Yes or no? No, yes. Anyone got this?
Yes, sir.
Everyone, all students? Okay, now let me do something just for you to understand that things can be different. I put the same question, but I just changed something. The value of mu is still 0.2. The force is still 40 newtons. But I now apply it at an angle. Let us say 37 degrees. And now you answer everything. Frictional force, normal reaction, reaction force, theta, and the acceleration of the block. I'll give you 2 minutes to do it. Yes, bacha, why it is taking so long? Shall I help you? Do you need any help? Yes, sir. No, sir. What do I do, sir?
Sir, we are trying.
Why is it taking so much of time, beta? Don't understand. Is it such a difficult problem? Okay, I'll give you time. Okay, I think I've given you sufficient time, and this is now the time for me to solve it. Shall I solve it? You're not able to do it till now. That means you are stuck into something that you should not have been stuck. Okay. First thing first, the weight is 50 Newton. The normal reaction is N. It is going to be accelerated in this direction. Yes or no? So frictional force will be here. Now this force is going here, 40 Newton. So I'll have to resolve it into two components. This is one component, this is the other component. Yes or no? This component is 40 cos 37. Cos 37 is 3 by 5. No. Cos 37 is 4 by 5. Yes or no? Do we know this? Yes or no?
Yes, sir.
So this component will become 8 into 4, 32 Newtons. Yes or no?
Yes, sir.
Is everyone there with me? Then the other component is 40 sine 37. Sine 37 is 3 by 5. So it will be 8 into 3. 8 into 3 is 24. So this component will be 24. Yes or no?
Yes, sir.
What is the first equation? You have to make first equation in the upward and downward direction. It does not move. Now look at the upward and downward direction. What is the value of normal reaction that you are getting? 26 Newton. Do we understand this?
Yes, sir.
Anyone got this?
Yes, sir.
So why did I give this question? To make you understand how I can change the normal reaction. I've changed the direction of the force, and that has helped me in changing the normal reaction. Do we see this, bacha? That was the reason of giving you this question. I have changed the normal reaction. I told you how to change frictional force. Either you can change the value of mu k. How do you change the value of mu k? To change the value of mu k, you have to change the surface. I am not changing the surface here. What I have done is I have changed the value of n. Do we understand this? Yes or no? No or yes?
Yes, sir.
Now I can find the value of frictional force. Frictional force will be 0.2 multiplied by 26. How much is 0.2 multiplied by 26? I think it will be 5.2. Yes or no?
Yes, sir. 5.2.
Frictional force is 5.2. Now you can find the value of reaction force. No one is going to ask you this, but this is 26 square plus 5.2 square. Yes or no?
Sir.
The value of tan theta still remains equal to mu. We can't change it. Yes or no?
Yes, sir.
Now we make this equation in the horizontal direction. We look at the forces in the horizontal direction. What is the equation in the horizontal direction? Tell me fast. 32 minus 5.2 is equal to m. M is 5 into a. From here, you should get the value of a. Do we understand this? Yes or no? No or yes?
Yes, sir.
Pakka, sir?
Yes, sir.
Shall we move on? Shall we move on to the next question?
Yes, sir.
Has everyone noted this one? Shall I give you the next question, beta?
Yes, sir.
Okay. I have a block which is kept at an angle theta. The mass of the block is, let us say, m, and the value of kinetic, the value of the kinetic friction, the coefficient of friction, let us say, is 3/4. Now the question is, at what value of angle theta I can change this inclination? I can make it smaller, I can make it bigger. At what value of theta will the block slide?
37 degrees, sir.
Well done. Do we understand the answer? At theta is equal to 37 degrees, the block will start to slide. No one can stop it. Question number, this is question number A. Question number B. If theta is equal to 53 degrees, find the acceleration of the block. I think you can find the rest of the things. No one is going to ask you that. I just asked you because they might ask you in some question. The only thing they are going to ask you is the acceleration. Get me the acceleration of the block. 2 minutes. And you will not get more than 2 minutes for this one. Yes, do we have anything that looks like an answer?
Yes, sir.
Well done, sir. Fatafat. The weight is mg, yes or no?
Yes, sir.
This is
mg
mg sine theta, yes or no?
Yes, sir.
This is
mg cos theta.
mg cos theta, yes or no? This is
Sir.
normal reaction. It is going to go like this. Frictional force will act in the backward direction, yes or no?
Yes, sir.
What will be the value of this frictional force?
9/20 mg, sir.
Okay. So we can make the equation. It will be going like this, yes or no? Acceleration will be like this. My normal reaction, if I make the equation for normal reaction will be mg cos theta, yes or no? No, yes.
Yes, sir.
So my frictional force will be equal to
3/4
mu times. So mu is 3/4. So let me write it 3/4. Let me write it as mu only. So I just get the general result. Mu into mg cos theta, yes or no, my dear friends?
Yes, sir.
So what will be the value? What will be my equation in this axis? Acceleration is like this. Downward force is like this. Upward force is like this. Yes or no? If I
Yes,
write
sir.
the equation, it will be
mg sin
mg sine theta minus mu mg
cos theta.
mg cos theta will be equal to m into a. A is not required. A will get cancelled. I will get my acceleration as g sine theta minus mu g cos theta. Yes or no?
Yes, sir.
That is the answer that we were looking at. Everyone got this answer?
Yes, sir.
Do we understand what we have got?
Yes, sir.
What? We have got the acceleration of the block when it is having a frictional force. We will continue with this topic in the next class and we'll try to wind it up by the next class. We are doing kinetic friction. We'll do some problems on the blocks which are connected as well, and we will see what difference does it make when what? When friction comes. Remember, friction is just a force. We just have to find out the magnitude of that force. We just have to find out the direction of that force, apply it in the direction opposite to relative motion, and the rest of the question is as what we were doing. Yes or no?
Yes, sir.
So we'll continue with our discussion in the next class. We'll see you. I hope you will be trying questions from the sheet. That 200 question also has question on friction. They are less, so I'm doing it here. Whatever question I do in the class, that is more than enough for you to do in friction. You don't have to do anything else. Okay?
Okay, sir.
Try question from the Newton laws of Newton laws part. There might be question that you are not able to do it now because they may have pseudo force. We will do it. Don't worry. Take care. If you have any doubt, please let me know. But steady, and please solve that 200 question as soon as possible by Sunday, because by Monday we might start with a fresh new topic. Okay?
Okay, sir.
So do it. Take care and have a nice day. God bless you all.
Thank you, sir.
Bye.
Have a nice day.
Bye.